Alrighty, today's lesson is going to be on ratios and proportional relationships. And the standard this aligns with is the Common Core State Standard of 7RP.A.2.B. This standard has grade 7th, ratios and proportional relationships, where we recognize and represent proportional relationships between quantities, identify the constant of proportionality, or also known as unit rate, in tables, graphs, equations, diagrams, and verbal descriptions of proportional relationships. Today's warm-up question, we're going to use a pizza. Alrighty. We know that on average, or I guess the common standard would be, one pizza is usually about or has 8 slices. You can see we got 8 slices here all kind of split. And we're going to come back to this later, but we'll see this later, I should say. Pizzas also can be known as, or is called, a pie. So first, let's go over some key features of proportional relationships. We know that the ratio is constant, meaning if, for example, we have one pizza, we know that has 8 slices. So if we have 3 pizzas, it's going to have 24 slices. The ratio is the same. We also know that these quantities have a direct relationship where they change at the same time. For example, and the previous example, when we increase the number of pizzas from 1 to 3, we triple it. And we also note that the number of pizza slices triples as well. Same thing if we double it. We also know the number of pizza slices would double as well. And whenever we graph proportional relationships, they must go through the origin. And that is because if we have 0 of one quantity, or in this case, if we have 0 pizzas, we can't have any pizza slices. So now we'll transition the pizzas into apples. Ben is at the local farmer's market looking for apples, and eventually spots a vendor who has apples. He then, after leaving the stall and purchasing some apples, Ben has spent $8 and gained 4 apples. What was the cost per apple? Alrighty, from this we know that each apple costs $2 because we take in the $8 he spent in total and divide that by the 4 apples he received, and we get $2 per apple. Now, shortly after leaving the apple stall, Ben remembers, oh wait, I need more apples than this. I got to make an apple pie. But Ben only has $32. How many more apples could Ben purchase? We're going to use the formula for proportional relationships. Y is equal to kx. Let's talk about k first. In this case, k should be, the unit rate we previously worked with, because we know, again, the price of one apple is $2. And so we know Ben has $32, and if he spends all of his money, that means he can get a total of 16 apples. Now let's do some graphs. Which graph is correct in representing the proportional relationship between apples and their cost? In this case, it will be graph B, because we know for 2 apples, that costs $4. Alrighty, it's time to move on to apple pies. We are now at later. Remember when I said we'll see pies later? Okay. Ben has left the farmer's market and returned home to start making those pies. The recipe online said he needs 5 apples to make 1 apple pie. If Ben wants to make 4 apple pies, how many apples are needed? Let's use this table. From here, we see 5 apples makes 1 apple pie. So, how many apples do you think it would take to make 2 apple pies? How many apples do you think it would, or if we have 15 apples, how many apple pies can we make? See, we get 10 apples to make 2 apple pies, and as such, 15 apples to make 3 apple pies. So we know that to get 4 apple pies, we need a total of 20 apples. And as you can see on this table, as we increase the number of apple pies by 1, we notice we always increase 5 apples. That's because they have a direct relationship with each other. Here are 4 apples. The end.